Okay, just take a look around you for a second. The building you're in right now, the sidewalk outside your window, those massive bridges you drive over, chances are they're all made of concrete. I mean, it is literally the foundation of our modern world. But because it's everywhere, we kind of just take it for granted?
But here's a thought. How do we really know that stuff is strong? I'm not talking about just kicking it to see if it's solid. I mean, deep down, at the atomic level, where all that strength actually comes from. How can we be 100% sure that the chemistry, that magic that turns a bunch of powder and water into solid rock, has actually gone right?
Well, for the longest time, seeing that was, well, pretty much impossible. But it turns out the answer isn't about seeing at all, it's about listening. Listening to the faint, tiny whispers coming from the individual atoms inside the concrete.
So, how do we listen to these atomic whispers? Well, that brings us to the hero of our story today, a technique called solid state nuclear magnetic resonance. You can just call it NMR. Now, that might sound complicated, but I bet you're already familiar with the basic idea. Ever had an MRI scan? Well, NMR is basically an MRI, but for molecules. It lets us get this unbelievably detailed picture of what's happening at the atomic level. Okay, so how does this whole thing even work? Well, it all boils down to a neat little property called nuclear spin. It's pretty cool, actually. The nucleus of certain atoms, and this is key, atoms like silicon and aluminum that are all over cement, they act like tiny spinning magnets. Just imagine a microscopic little compass spinning away. Now, here's where the magic happens. You take these atoms and you stick them in a really powerful magnetic field. And what do those little compasses do? Snap! They all line up. They can either point with the field or against it, and those are two different energy levels. So then we come along and we hit them with a very specific radio wave, like a little ping, that makes them flip over. And when they flip back, they give off a tiny little burst of energy. And that is the atomic whisper we've been talking about. And an MRI? That's our super sensitive microphone that picks it all up. All right, so we're diving into the problem with solids. And believe me, it's a big one. You see, this whole technique works beautifully for liquids. Why? Because the atoms are just tumbling around, doing their own thing, and they give off these really sharp, clean signals. But for a solid, a rigid material like concrete, oh, that's a whole different story. That's where all our beautiful signals just get lost in the noise.
Think about it. In a solid, the atoms aren't free. They're locked in place. So each little atomic compass isn't just feeling the big magnetic field we apply, it's also feeling the tiny magnetic fields from every single one of its neighbors. It's like trying to hear one person whisper in the middle of a screaming, sold-out stadium. It's impossible. All those individual whispers just get completely smeared together into one big, blurry, useless mess.
And this right here, this is what scientists would actually see on their screens. Instead of nice, sharp peaks that tell you something, you just get this wide, featureless blob. It's nothing but static. And for decades, this problem, which they call line broadening, made it almost impossible to learn anything useful from materials like cement. All its secrets were just locked away inside.
Until a truly brilliant breakthrough, a technique that is so clever, it almost sounds like science fiction. It was a total game changer, and it's called magic angle spinning, or MAS for short.
So what is this magic? The best way to think about it is like a tiny laundry machine, but for atoms. Here's how it works. First, you take a little bit of your cement powder, and you pack it into this teeny tiny cylinder called a rotor. Then you spin that rotor at just insane speeds. We're talking faster than a jet engine turbine, thousands of times a second. But, and this is the real secret sauce, it's not just about spinning fast. The real trick is the angle you spin it at. That specific, almost mystical angle, it's 54.7 degrees. That's it. Some very smart physicists figured out that if you spin a sample at precisely this magic angle, something incredible happens. All of those complicated, noisy interactions between the atoms, the stuff that was causing all the static, they all just mathematically cancel each other out. They average to zero. And the static, poof, it just disappears.
And the result? I mean, just look at this. It's absolutely stunning. That big, useless blob transforms into this beautiful spectrum of sharp, clean peaks. The jumbled roar of the stadium suddenly becomes a collection of individual, crystal-clear whispers. And every single peak you see here, that's an atomic fingerprint. It's telling us exactly what's going on inside that concrete. So we can hear the whispers, we have the fingerprints. What are they actually telling us? This is where all this cool science really hits the road and helps us build a stronger, safer world. You see, the position of each of those peaks on the chart, it's something scientists call the chemical shift, is like a unique address. It's a direct signature for a specific atom sitting in its own specific chemical neighborhood. So we're not guessing anymore. We are seeing the exact molecular building blocks that make up the concrete. And look at just how precise we're talking. If we see a peak at -71.3 on the scale, we know without a doubt that we're looking at a compound called belite, which is super important in cement. See another one at -82.2? Bam, that's graphite, a totally different compound that forms when it hardens. It's like having a complete atomic level parts list for a piece of concrete.
But wait, it gets even cooler than that. We can actually use this to watch the concrete come to life. So in the dry cement powder, NMR tells us that the aluminum atoms are all arranged in this four-sided shape, a tetrahedral structure. But then you add water, you let it harden, and you look again, and the signal has changed. Those same aluminum atoms have completely rearranged themselves into a new, stronger, six-sided octahedral shape. We are literally watching the chemical reaction that gives concrete its incredible strength happening in real time. So when you put it all together, what does this mean? It means that NMR gives us this completely unprecedented, direct look inside one of the most important materials on Earth. We can identify every little component. We can understand exactly how it hardens and gets strong. We can even track how additives, things they put in to make it set faster or last longer, are actually working at the atomic level. And all of that knowledge, it goes straight to the engineers, helping them design better, stronger, and more durable concrete for everything.
It's really just an amazing story of scientific creativity, isn't it? By figuring out how to turn this jumbled, chaotic roar of atomic noise into a set of clear, understandable whispers, we've literally unlocked the secrets to making the foundations of our world stronger and safer. And it kind of makes you wonder, right? If we can learn all this just by listening to a block of concrete, what other incredible secrets are just waiting to be discovered, hiding in all the other everyday materials we're surrounded by?